Hello everyone. Today I want to talk about my project using the USDA food nutrition dataset to predict variables of interest by using support vector machine and also neural network. So first I will begin with some data description, and then followed by the methodology that I used, and then followed by the results from using the support vector machine and also backpropagation neural network, and finally some conclusions. So first is the data description. So I got this data. So the data set is USDA food nutrition data. So the data resource is from the StatsCrunch website. So I got four categorical variables. So basically, they are just very basic description of the nutrients of the food, and there are 12 different numerical variables, that is the nutrients of a specific food. So after cleaning the data, I got a data size of 7,855 observations. From the list variables list, the most important variable that I care about is calories and sugar, because calories can cause a lot of people to get probably overweight, and sugar can cause some people to get diabetes and some other disease. So I would focus this project to these two parameters. So first what I did is to plot the correlation matrix to observe what correlation the variables have between them. So for example, for calories, we can see from the second column, it has a lot of relation, has a very strong correlation with water and also fat and also carbon. And from the seventh column, that is the sugar, we can see that is also highly correlated with water and also carbon. So next, what I did, so for the methodology, so that study attempts to analyze the food nutrition data to find some patterns of relationship between nutrients, for example, calories and sugar with other nutrients. So first, I used the support vector machine to test if different predictors combination can accurately predict calories and sugar. So first, I labeled the calories and sugar with the range with a class of 1 to 10 based on the scaling normalization. So then I tried different combinations to predict calories. The first three combinations are using the sugar and fat to predict calories, using water and fat to predict calories, and the fat and carbon combination. And I also tried to use water and carbon to predict the sugar. And finally, ANN neural network is also utilized to predict calories with basically all other nutrients as input. So first, I tried to use a support vector machine. So first, I tried the combination of sugar and fat to predict calories. So I tried different box constraints and kernel scales, which are basically the parameter C and the parameter gamma. So different values are tried, and I found the accuracy is approximately near 79%. So from the plots, I think and also the values of the accuracy, I think relatively not very significant overfitting is observed by plotting out the accuracy. So for example, if I vary the box constraints just with the auto kernel scale, I think I found that the peak accuracy that is reached by using the box constraint of just 1.0, and then I varied the kernel scale with this box constraint, and then I found the peak is approximately 69%. And next, I used the water and fat to predict the calories. So I think for this combination, the trained SVM model becomes a little bit overfitting, so the maximum accuracy can actually reach 93%. And then I used the carbon and the fat to predict the calories. This time I think the accuracy. This time the accuracy is actually very low comparing to the previous predictors combinations. So the box constraints are varied from 1 to 30, and the kernel scale is I used auto, so it's just automatically selecting the appropriate scale. So the maximum, the peak accuracy is reached when the box constraint is equal to roughly 17. So I got an accuracy of 10.2% of the accuracy. Which is a relatively low value. And finally, I try to use water and carbon to predict the sugar. So roughly it can reach 80% accuracy, and I think it probably showed a little bit overfitting. So the accuracy, and another thing I found is that the accuracy shows very small sensitivity to the kernel scale. So after I found that the peak accuracy by varying the box constraint, and by doing so, I found the box constraint is equal to 0.8, and then I varied the kernel scale with this box constraint value. The accuracy does not change very much. It's always like 79.5% of the accuracy. Yeah. So this is the results that I got from using the support vector machine to predict the calories class. And then I try to use the backpropagation neural network to predict the calories, basically with all the 11 other variables as input. So for the network type, I used the feed-forward backpropagation, and I used the LM training function, and I also tried different hidden layers to predict the output, and I think 5 layers is found to produce relatively appropriate results by comparing the best mean square error, the MSE. So for the calories prediction, I think different neurons per so I use the different neurons per hidden layer to vary the value to see how they're going to change the performance of the model. So I think and simply by increasing the neurons to even larger number is not always a solution. So from this table we can see that basically if we use 6 or 8 or 10 neurons per layer, the mean square error is roughly all about 160, and if we increase this neuron number to a higher number, it's not going to increase the performance of the model. So I think the best performance is actually achieved by just using 10 number of neurons, but using 6 and 8 is approximately the same accuracy. This plot shows the model performance and the training state. So from the left figure, we can see that the best validation performance is reached at the iteration number 58 out of the whole number of 64 apex. And from the right figures, so it plotted the gradient, the mu, and also the validation checks. And we can see that at the end of the epoch, the validation checks actually have a few number of 6. And I also plotted out the regression, and also I also look at the error histogram. So from the left hand side figures, we can see that the training regression is all. So actually, I use the different values of hidden layers and also the neurons. But for the regression plot, I think for the regression fit, the R value is always very, very high and very close to 1, no matter it's training or validation or test or all of them. So the R number is always very close to 1. And by looking at the prediction error histogram, the minimum and the maximum range of the error is just from -50 to +50. So I would say the prediction is almost prediction error is almost centered at 0, and the prediction error is not a very large range. Yeah, comparing comparing to the full range of the calories, which is basically from 0 to 1000. And here are some conclusions. This project used both support vector machine and also artificial neural network to predict the parameters of interest like calories and sugar. The conclusion is that I think the objective of the SVM and the neural network is different because the SVM tries to identify the groups of the data, and the AI is trying to predict a certain a very specific and exact value of a variable. So SVM can provide more information. I think if the starting goal is to offer diet suggestions, that means that if we want to predict whether a food is how much the calorie of a certain food is going to fall into a certain level. In this case, it's better to use SVM. And for the SVM output, I think the water and fat predictions shows a little bit overfitting, and the carbon plus fat combination is a little bit very low accuracy, actually just 10% accuracy. And so relatively speaking, the sugar and fat predicting calories model, SVM model, is relatively better model. And for the AM modeling, I think it also provides robust results and suggests that the relatively best model is just a moderate number of neurons of 6 or 8 or 10 within hidden layers of 5.